Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to focus on clustering. Now clustering is commonly used, particularly by marketing, to perform customer segmentation. In fact, it's about grouping customers together, finding natural groups, effectively centers of gravity, and then the customers that are closest associated to those centers of gravities. And typically we're going to use the k-means algorithm for performing that, and that's something that's available with the PAL library. So here we've got some data. Let's have a look at some customer information. We've got about 150 customers, and we can see that for each customer we've got their lifetime spend, the more recent spend in the last quarter, how much they've spent with us, what their overall income bracket is, and also a loyalty factor, how loyal they have been to us. So we've got 4 pieces of information for each customer. What we want to try to do is identify some natural groupings around that. Now, if we were to look, we could already maybe take a quick analysis, and for each customer, let's put that on the label, we might look at their income, and we might look at their loyalty factor. And maybe if we do a scatter plot, so we can see this is the 150 customers all plotted, and we can see for each customer where they fit when we look at loyalty against income. And we can see already ourselves here we maybe have some natural clusters. There's maybe 2 natural clusters or natural groupings of customers that are kind of in the same area. So in fact the k-means algorithm is actually going to automate this process and allow us to do it mathematically. And that's important because here we're just looking at 2 dimensions, but actually we have 4 dimensions in the data. So obviously that's much more difficult to do visually. So we need to find some code, and as always I've got a little bit of code prepared. Again, consult the PAL reference guide to get more details. But basically for the k-means algorithm we have an input data. It's similar to what we already saw, an input table where we need an integer ID for each customer or whatever we're looking at, and then we've got our set of variables we want to be analyzed. We've got a parameter table, and we've got 2 output tables. We've got one output table which we'll call results, and that basically will tell us which cluster, which segment the algorithm has assigned that customer to. And also we'll see a table called centers, which basically tell us where the center points, the center of gravities are for each cluster that's been decided. So we'll go through, we create the signature file as always. It's the k-means algorithm that we need to create, and we'll create a function called pal_km. So let's go ahead and run that. So we've created our procedure, and now in our application setup, what we want to do in our PAL schema, firstly, because the PAL function does require a certain set of data in a certain order, then we're going to create a little view on our customers table. We're going to get rid of the customer name. We're just going to give the customer's ID because that's what the function expects to see, plus the 4 pieces of information. Now of course in the real world, in your own applications, this is a great point with doing this view to maybe filter or do some manipulation on the source data. You don't have to physically copy the data into a new table simply just to call the k-means algorithm. And for the parameters, the results, and the centers, we can create tables based on the table types we already did a moment ago. And also I've created a view, and we'll see why that's interesting later, but effectively the results we get here in the regular results table gives for each ID, it gives the cluster it belongs to. However, it can be very useful sometimes for analysis to actually see the input data as well, the actual lifetime spend, new spend, and then see that in the context of the clusters. And the other thing that the clusters that are created actually start from 0. So we have clusters, if we have 3 clusters, we have 0, 1, and 2. Whereas for analysis, it can be simpler, particularly for a business audience or a data analyst, to show clusters starting counting from 1. So we've got this code, we can run that. Now there are a number of different parameters that you can use to set with the k-means algorithm. There are actually 7 different that go in the parameter table. Some of these involve seeding in terms of how the algorithm gets started, or normalization. Also about how many threads to use. The one that's very much relevant and used almost all the time is the thing called the group number. And this is where we specify how many clusters, how many segments or groups we want to be created, because we can set that to any number we want. So we've now set that up. We can go to the runtime. In this case, we've not run it already, so we can just simply go and run our procedure, pointing to that input view with the parameters, and we'll get two tables out that we can then analyze. So let's run this against 150. It's very, very fast, but I should emphasize that the actual algorithm behind this involves iterating the entire data set multiple times until it finds a natural and good set of clustering. So it's a very data intensive algorithm, very well suited for working with HANA. So if we now refresh our list of tables, we will see that we have KM centers and KM results. So let's have a look at those tables. Let's interpret some of the results we've seen. So if we go to the centers, we can see here it's created 3 clusters starting from 0, 0, 1 and 2, and we've got for each of the 4 input variables, it's basically telling us where is that center of gravity in the data. Now, if we remember, we went back to the customers. This was looking at loyalty and income for each customer. If we were to look at the centers in a similar way, we can actually show the income and loyalty and do that by the center and scatter that. We can actually now compare. This is effectively where the k-means algorithm has identified the center of the 3 clusters, because we asked to see 3 clusters. So that's all of the data, the original input data, and now we can see basically where the algorithm has found the 3 cluster centers. Now, that's interesting just to see the information on where the centers are for each cluster. Again, we're looking at just 2 dimensions here, but in reality there are 4 different dimensions all working in parallel. What we can also now look is at the results table. So if we look at the results table here, what we can see is actually for every input customer ID, and there are 150 of them, it's assigned us a cluster, which it calls the center ID, from 0 to 2, because we have 3 clusters. And it also gives us the distance, how far this individual customer is from that center point we were looking at. Just to give a little bit of analysis, what we could do, for example, is look at center ID here and just count. So we can see, for example, how many customers have been put into each of these customer segments. So we have a fairly balanced. And it's important when doing this analysis that you want to make sure that your clusters are well balanced, that you don't have 99% of customers in one cluster. Because probably that's not maybe representative of what you're trying to do if you're setting up a sales promotion. What we can also do is look at the results view. So if we look at the view for the k-means results, and this is where we can do a bit more analysis, looking not only at the input data, so we have the customer name even, the lifetime spend, the 4 variables, but we've also got now the cluster number. So that means we can do a little bit more interesting analysis. So for example, what we can do is again produce a nice chart. We can go with the customer ID or the customer name. In fact, what I want to do is look at the income and the loyalty as before, and we can see that by customer, and in fact that represents what we saw in the input data. But what I also want to do is put in the cluster number, and if we just change the order there, what we can see now is that the input data, we can see actually how the clusters visually are represented across these 2 dimensions. So we can see all of the data points, all of the customers plotted, so we can see where those 3 clusters naturally fit. And of course, if you want to bring in another variable, for example, the lifetime spend, we could do that. Maybe in this case, we could try to represent 3 dimensions through a bubble chart. That maybe is another way of doing it, although it's not necessarily so easy to visualize on a flat screen like this. So now we've seen basically how the k-means algorithm works. I wanted to show just one further example, and that is to actually run this again, but this time, because HANA is very scalable, it can work with big data, not run against 150 customers, which is fairly trivial, but actually we're going to run against 1 million customers. So I have got another table with 1 million customers in it, and I'm just going to drop the view that we already had, and say this time point at 1,000,000 different customers, okay, we're going to clear out the output data for the next run, and maybe this time we'll ask for 5 clusters, not 3, but let's go for 5. So we can update our parameter table, and now we'll run this. So we're going to run this very intense algorithm against 1,000,000 different customers. It's going to do multiple passes of 1,000,000 rows. And in fact, it's done that in just 3 seconds. That's really showing the in-memory power of HANA and how that this in-memory predictive capability is extremely powerful when you run that in the database and not separately on an app server or downloading to a workstation, which is what people have often done in the past for performing k-means. And now if we go back to our results table and refresh that just to prove the point, you can see that we're counting the customers. So of our 5 distinct clusters we've created, you can see how many customers have been put into each, and that adds up to just over 1,000,000. So very, very powerful capability with HANA in terms of processing very large volumes of data, performing extremely complex analysis, and doing that very, very quickly in a scalable way.